Let's go ahead and get started then. This section is 2.5. It's more on linear equations. So some different forms of linear equations and then some other fun things that we can do. And are you ready for this? I'm going to say story problems. Your response is?
Yeah.
That's what we're after. That's what we're after.
Nobody else was happy. No.
And let's see, so we're missing Amelia and Sarah Brown, right? Okay. Okay, so just a quick review. We've been spending a lot of time talking about linear equations. If we're going to graph an equation of a line or write the equation of a line, we need two things. Please don't forget these. You've got to have at least one point, and then you've got to have the slope, or sometimes they give you enough information that you can find the slope. And this phrase right here is going to be really important. Sometimes they won't give us the slope, but they will give us enough information that we can figure it out. Okay? Now, we mentioned this before. Most people like slope-intercept form. Quick reminder, slope-intercept, y equals mx plus b. Got a y on one side, a number in front of x on the other, plus some constant or minus some constant. If it's in that form, we'll call that a nice graph-friendly form because you can look at it, tell where it crosses the y-axis, and tell what the slope is, and then you can just sketch the graph from there. That's not the only way to write a linear equation, nor is it the only graph-friendly form. There's something called point-slope form. Okay? Point-slope form looks like this. You've probably seen it before. Just a quick reminder. That's the variable y, that's the variable x, but there are some other things floating around here. This is y1. This is the y coordinate for the point that we have. This is x1. This is the x coordinate for the point that we have. And that, of course, is m. It's the slope, okay, just like it is in slope-intercept form. Now, the cool thing about point-slope form is, right in the name, just like with slope-intercept, okay, it tells you everything you need. If you have a point and a slope, plug it into point-slope form, you're done. That is an acceptable linear equation. It's also used a lot in higher mathematics. And if you were to go to Europe or some other country, a lot of times they don't bother with slope-intercept form. They just leave it like this, okay? Or they might slide this y1 to the other side and make it positive. But it's a nice graph-friendly form, just in a different way. There are some huge advantages to having those two y coordinates together and those two x coordinates together that in higher mathematics make a big difference. So it's not something that you say, hey, my teacher showed me that a couple years ago. I really didn't like working with it. I would take the time now to get used to it, because like I said before, I've taught all the math classes that you potentially could take. So I'm telling you this for a reason. If you get comfortable with this, there are things down the road that are going to make a heck of a lot more sense. Okay? So let's take a look at an example. It says, find the equation of the line that has a slope of 3 and goes through that point right here. Now, because the problem didn't say express it in a particular form, if you have a slope and a point, plug them in. Y minus y1 equals mx minus x1. And let's plug in those things. So this is going to be y minus. Write the minus, then go find the y coordinate. What's the y coordinate? 2. Equals the slope, m, 3. X, write the minus, then go find the x coordinate. What's the x coordinate? -1. So what do we write? We write +1, and that is the answer. Whoops. That'll happen occasionally. That's the answer right there. That's it. Okay? There's the answer to our problem. We said come up with an equation. There's an equation right there. Now, I will show you this. If you wanted to put this in a calculator, this won't graph on a calculator. So what we'd want to do is this. We'd want to move the 2 to the other side, and we'd have this. We'd add 2 to both sides. Okay? Now, don't worry about writing that down. This is the answer in point-slope form. This isn't slope-intercept or anything else. It's just another form that we could use to graph the line. Okay? This next one. Okay. Any questions so far? Am I going too fast? Yeah.
Well, just on the equation that you just wrote, yeah, that one, you can just, like, if you distribute the 3, you can make it into slope.
Yeah, you could put it in slope-intercept form. Parker's correct. You could quickly put it into slope-intercept form. Questions there? It's pretty easy on this one because they're nice whole numbers. Let's take a look at the next one. So the next one says, Find the equation of the line that has a slope of 3/5 and goes through that point right there. So again, y minus y1, m times x minus x1. And the reason I'm writing this and saying this several times is it's going to help you get it memorized. So this is going to be y minus, go find the y coordinate. What do I write? Plus 3. Slope is 3/5. X minus, write the minus, then go find what the x coordinate is. It's a 1. Okay, this is the answer right there. Now, if we do the same thing on this one that Parker suggested on the last one and we distribute through after we've moved this over, we'd have this. Y equals 3/5 x minus 1. Whoops. X minus 1. And then this would be minus 3. Distributing through. Now, this part isn't the problem. 3/5 x. I mean, that's okay. We're used to having fractions in front of the x. But then we're going to have negative 3/5 minus 3. How would I put those numbers together right there? I'd have to get a common denominator, right? So then I'd have to do a little bit of work here. This is 3/5. Let's see, this technically is over a 1. I'd have to make it a 5, so this is going to be 15/5. So then I get 18/5, negative 18/5. So if I wrote this in slope-intercept form, 3/5 x minus 18/5. Takes all that work when we're working with a fraction to put it in slope-intercept form. So slope-intercept here, point slope here. Which was easier to get? Point slope. Okay, so can you see why sometimes it might have an advantage? If they don't say write it in one form or the other, if a problem's written like that, point slope form really is a quick way to get the answer. Okay, next one. Find the equation of the line that goes through negative 4, 3 and 2, 5. We're going to write the equation of the line. What two things do we need? It's at the top of the page. Do you have this memorized? Don't forget it. What do you need? You need a point. Do we have a point? Yes. Do we have a slope? No, but we have enough information to figure out what the slope is. So I'm going to call this x1, y1 and x2, y2, and let's go to work. Let's see. First of all, let's figure out what the slope is. y2 minus y1, so 5 minus, go find the y coordinate. x2 minus, write the minus, go find the other x coordinate. 2 on the top, 6 on the bottom, 1/3 for our slope. How are we doing there? Y minus y1, m, x minus x1. So which point do you want to use? Does it matter? Doesn't matter at all. I'd usually pick the one with the smallest numbers and the fewest number of negatives because you tend to make fewer mistakes. On this one, those are kind of smaller numbers, okay? Those are more positive. It doesn't really matter. Let's go ahead and use this one right here since I have it labeled x1, y1. So this is going to be y minus 3. This is going to be 1/3 and x minus a minus 4, so that's going to be plus 4. Now, if the problem didn't specify and you could leave it in point slope form, we're done right there. If the problem said, hey, I want you to write it in slope-intercept form, now what do we have to do? Yep, we got to convert it. So we're going to need to do two things. Move the 3 over, and we're going to need to distribute. So this is going to be y equals 1/3 x plus 4 plus 3, which is 1/3. Can I blow this up a little bit? Pretty okay there? 1/3 x. What is 1/3 times 4? 1/3 times 4. 1/3 times 4 over 1. When you multiply fractions, you multiply the numerators together.
1/3.
4. Multiply the denominators together. Thirds plus 3. So we're almost done. We like the 1/3 x. We need to put these guys together, which means we need to get a common denominator. So 4/3 plus 3 over 1, or that needs to be 3, 9, 13/3. Okay with that? So it's y equals 1/3 x plus 13/3. Again, If you have a fraction for a slope, writing it in slope-intercept form is a pain. It's tough to get either way. If you put it in this form, everybody watch please. Okay, so you don't need to write this down. If you wrote, well, I know the slope is 1/3, I just need to find the b, then you'd have to plug in this point or this point in here. Either way, you're going to have to do some fraction arithmetic. Okay? So either way, it's no fun. Okay, any questions? Okay, next one. Would you try that one, please? Try example 4. And just stop at point slope form. When you're done, just check your answer with your neighbor. See if you got the same thing. If you did, you're probably right.
Wait, how far are we supposed to go? Just point slope?
Point slope.
Okay, it's not intercept.
So y2 minus y1 is going to be -4 minus -1. And x2 minus x1 is going to be 3 minus -1, so that's going to be +1. So this is going to be -3/4, so I've got -3/4. There's my slope. Y minus y1 equals mx minus x1. So this is going to be y minus. I'm going to do the first one, so that's going to be a +1, -3/4 x +1, and there's my answer. Okay? Now, my question for you is, would this one be very hard to put in point slope form? Or sorry, slope-intercept form? No, because when you distribute through here, it's got some 1s in there. It's going to be pretty easy, pretty small fraction problem. Okay? And can you fill in the next lines here? Without looking back at your notes, just thinking. So if we said y equals a number, that was a certain type of line. And if we said x equals a number, that was another type. I suppose you've got a 50-50 chance, but it would be nice if we just knew this rock solid. Y equals a number is horizontal. So that means x equals a number is vertical. And you'll remember we kind of reasoned our way to this by saying, if it's y equals a number, it tells us what the y coordinate has to be. X can be anything you want, so you're running this way. If it's x equals a number, it tells you where you go on the x-axis, go over to here, and then you can go as far up or as far down as you want, so that's got to be a vertical line. Everybody clear there?
Yeah.
Okay, so if that's the case, then let's take a look at the next couple of examples, because this one is different. We're still trying to write the equation of a line, but it says this. Find the equation of the horizontal line that goes through the point 1, 2. Now, if say this was on an ACT, and we went through and we said, okay, well, let's see. It goes through 1, 2, and it's horizontal, so it looks like this. How could I write the equation of that line? If you don't know this, you're stuck. If you know this and you think about it, okay, that's a horizontal line, so that's going to be y equals, let's see, what's our y coordinate here? They're all 2, so it's y equals 2. The quick way to do this is to say, well, wait a minute. If it's horizontal, I know it's y equals a number. Which number would it have to be if it's going to be y equals a number? Would it be the x coordinate? No way, it's got to be the y coordinates, so it's just going to be y equals 2. So let's do the next one using that same thought process. If it's a vertical line, it's x equals a number. Which number would it be?
1.
It's going to be the 1, and there's the answer. Now, if we look at a graph, we could say, hey, it's a vertical line. It goes through this point right here. Yeah, look at those. They all have an x coordinate of 1, so it's got to be x equals 1. So you can reason your way to it fairly quickly, but it's also very nice to know, hey, if it's horizontal, it's y equals a number. If it's vertical, it's got to be x equals a number. Any questions? Okay, go ahead and flip the page over. Sounds like most everybody has already. Okay, I just want to call your attention to this. Here's the end of yours. Okay, I do have a couple problems that we're going to take a look at on a separate page. Okay, I didn't want to copy those off for you, but you do have some problems that are like that. They are the story problems, and let's hear it. Okay, that's very nice. That was lame. Okay, so this one says if you're given a linear equation in slope-intercept form, you can quickly identify the slope in a point. So, state the slope and the y-intercept. Not in slope-intercept form. So let's move it around. This would be 2y equals negative 4x plus 9. Divide by 2. So I've got y equals, I could stop right here, and what do I already know? I know the slope, and this would be plus 9 halves. We did some of this yesterday. So negative 2 is the slope, 9 halves is the y-intercept. Is this one good? Slope is negative 3/4. Y-intercept is 3. Pretty easy. I mean, it's not that bad. If this one has to be moved around so you can see what the point is on the y-axis, see what the y-intercept is, and move it around so you can tell what the slope is, we're in great shape. But with a little bit of practice, you can actually give a point and a slope just by looking at it in point-slope form. So remember, this is, let me change colors here, this is y minus y1. This is mx minus x1. Now, by far the easiest part of this to pick out is which?
Slope.
The slope. What's the slope?
Just the 2.
Slope is 2, okay, because it's the number in front of the parentheses there. Okay, now I need an x-coordinate and a y-coordinate. So what number is with the x? A 1, but remember, it's x minus 1. How did they make that a positive?
It's negative.
It must have been negative to begin with. So whatever the number is with the x, we do the opposite of that. So that's going to be a 1. And look at this right here. What's y1?
5.
It's going to be a positive 5. So again, the quick way to do this is to look at it, grab the slope, take the number that's opposite of the number with the y. So this is a positive 1, so we write a negative 1. This is a negative 5, so we write a positive 5. So there's the point and there's the slope. So let's do this one right here. Slope, negative 3/4. To write down the x-coordinate, find the number with the x, write down the opposite. So what do I write? 4. For the y-coordinate, find the number with the y, write down the opposite, so I write negative 3. See how easy that is? Okay. I think this is the last topic for this one. It is. Okay? So, parallel and perpendicular lines. So let's take a look at line L and line M, the blue ones here, and line L and line P. Okay, what do you notice about L and M?
Parallel.
Parallel. Or you could have said this. Okay, I kind of led you along. I used the words parallel and perpendicular just a second ago. You could also have said, you know what, they're sloped the same. And what about L and P?
Perpendicular.
Okay, they're perpendicular. Meet at right angles. So, you're probably already aware of this, but let's make sure we're clear on the details and that we're using the same vocabulary and saying this the same way. Parallel lines have slopes that are, okay,
Equal.
I'm going to say it this way, exactly the same. Exact in every way. If one's positive 5/3, the other one's positive 5/3. If one's negative 2, the other one has a slope of negative 2. Exactly the same. Perpendicular lines have slopes that are,
Exactly opposite.
okay, exactly opposite wouldn't be quite the right way to say it because there are lots of ways to say opposite, especially when we're dealing with fractions. Okay, what we mean by that is they are opposite. That takes care of the sign, and kind of opposite would be flipping. That is reciprocal. Okay? So they are opposite reciprocals of each other. Opposite reciprocals of each other. So if this one has a slope of 1/2, going up from left to right, this would have to be negative, and be a reciprocal, so it would have to be -2, okay? So please don't forget this, and I've got asterisks by these. So if you've been tuning out, I'd make sure you pay attention to this. Horizontal lines and vertical lines are perpendicular, and that's the symbol we use for perpendicular. And if somebody says, hey, are these lines parallel or are they perpendicular? What if it's neither of those? Guess what word we use? Very good, okay? We just say neither, okay? So if they're not parallel and they're not perpendicular, then we just say that they're neither. And the cool thing about this is, if you're asked to tell whether or not they're parallel and perpendicular, you don't have to graph them and look at them, okay? In fact, that's kind of a horrible way to do it, because sometimes looks can be deceiving. All you need to look at is what?
Slope.
Just the slope. That's it. So let's take a look at this one right here. You'll notice that neither of these are in slope-intercept or point-slope form. So let's move. Well, wait a minute. Look at this one. If they write things in the wrong order, they're usually trying to mess you up. They're usually trying to trick you. Okay? What's the slope here? +1. Let's do this one. 4y equals, this would be 4x minus 2. Divide by 4. Everybody watch, please. I get y equals, this would cancel to be x. Do I care that this works out to be -1/2? I don't. All I care about is that that's a 1, so the slope on this one is 1. Both of them have the same slope, so these are parallel. You can write the word parallel, or you can just do this. Okay? Either one. Any questions? Okay, if I move the x to the other side and divide by -2, I get y equals, this would be 1/2 x. Okay, technically it would be, -3/2. We don't really care about the halves there. And then on this one right here, if I move that over, I'd get 2y equals 2x plus 1, 4x plus 1. Divide by 2, I get y equals 2x plus 1/2. Hello, Sarah. Okay, what I'm interested in is the 2 and the 1/2. I hear some perpendicular, I hear some not perpendicular. Do the slopes look like they should be perpendicular? Yeah, one's a 1/2, one's a 2. They're reciprocals, but they're not opposite reciprocals. So the answer on this one is neither. Okay, and think about it this way. If this one slopes up from left to right and this one slopes up from left to right, there's no way they could be perpendicular to each other. Okay, so that one is a neither. And then let's look at the last one here. Slope on this one is 3. Pick it off right from the get-go. It's in function notation, but that doesn't stop us from recognizing that that's in slope-intercept form. So the slope is 3. If we move this one over, let's see. This would be 6y equals -2x plus 51. Divide by 6. I really don't want to do 51 divided by 6, and I don't need to, because this is y equals, this would be 1/3 x with a negative. So my slope here is -1/3. So I compare the two of those, and they are opposite reciprocals, so they're perpendicular. Okay? Any questions? Okay. You've got a couple problems on your assignment like this. It says write the equation of the line with the specified point that's parallel to the indicated line. Here's the point. Wait a minute. What two things do we need to write the equation of a line? Point and slope. There's the point. Why do I need this? To find the slope. So let's move this around. So this would be -2y equals -x plus 3. So this would be y equals, let's see, if I divide that by -2, I get 1/2. Okay, so here's what I have. The slope of their line is 1/2. If I want mine to be parallel, what's the slope of my line? 1/2. So I use that slope and that point. So y minus y1, mx minus x1. Y minus 5, 1/2, x minus 2. Point slope form. This one wouldn't even be hard to put into slope-intercept form. Can somebody tell me why this one's particularly easy to put in? Yeah, because if I distribute through a half, what's half of 2? A 1. It would be a whole number, not even any fractions to work with as far as the y-intercept on that one. Okay? Questions there? Okay, let's look at the next one. Here's the point. What I need from here is the slope. So this is going to be negative 5y equals negative 1x plus 1. Divide by negative 5. What I care about is their slope is 1/5. I want ours to be, parallel. So ours is going to be exactly the same, 1/5. So between this point and this slope, I plug those into point slope form. Are we okay if I just don't finish that off, or do you want to see that? We're good? Okay, let's look at the next type of problem then. Okay, it says write an equation of a line that contains the specified point and is perpendicular. So we want that point, and let's find the slope here. So this would be 4y, negative 5x plus 1. What we really care about is this is negative 5/4 x. So if their slope is negative 5/4, and we want ours to be perpendicular, our slope would have to be opposite reciprocal. Opposite sign is going to be positive, and if we do the reciprocal, that's 4/5. So I'm going to take those two things and plug them into point slope form. Y minus 0, 4/5, x minus 6. That's the answer in point slope form. Yeah.
So if we ever get that, the y minus 0, do we have to 0?
Yeah, you could just write y equals, and the cool thing about this is you can write y equals, if you wanted to write this way, that would be fine. If you wanted to distribute through and write it as 4/5 x, and then this would be negative 24/5, that right there would be in slope-intercept. Okay? All right. Okay, can I slide this over?
Yes.
Okay, take a look at the last one. The last one's a little bit unique. Does anybody notice anything about this? It's the y-intercept. They gave you the y-intercept. You know B would have to be 6 on this one. So remember, it didn't specify whether to write it in slope-intercept or point slope, but if you've got the y-intercept, all we need is the slope. So let's find the slope. And lo and behold, it's already there. Slope is 2. So this would be y equals 2x plus 6, and we're done. It's that quick. Okay? So don't overlook things like, hey, that looks weird, but it's still in slope-intercept. Hey, that's a special point. That is the y-intercept. So I can just write that one down. Okay? All right. Last one on this page, and then we're going to take a look at the story problems on the next page, because you do have a couple of those on the assignment. It says, write an equation of a line containing the point 2, 1 that's perpendicular to the line x equals 4. So don't say anything out loud. Think about this. What type of line is this? Ingrid, what is it? This is vertical. What's perpendicular to vertical? Horizontal.
Just take the line.
So if it's a horizontal line, it's y equals a number. Which number would it have to be? It would have to be the -1, so y equals -1. Now, if you wanted to graph this line, graph that point and say, hey, I've got this vertical line over here and I need a horizontal one to go through here and figure it out that way, that's okay. but a lot easier to reason your way through there. Questions? Yeah. Oh, you're right. You're right. Thank you, Ari. Okay, thanks for pointing that out. Remember, this was their slope. We wanted our slope to be perpendicular. So this should have been -1/2. So I'll fix that by just changing this to -1/2. Thanks for being on top of that. Very good. Okay, any questions? Okay. Nobody tuned out? Everybody caught that mistake? Okay. You were just letting me suffer, right? Okay. All right. Just really quickly, please remember that we've talked about slope-intercept and point-slope form of a linear equation. This is called standard form of a linear equation, and we do use that quite a bit. Okay? So there are lots of different forms of linear equations. Remember, linear equations have plain old x's, plain old y's, or both, okay, which is what happens in most cases. I do want you to read page 153 before next time. So tomorrow is office hours, right? Okay. If you have work to do tomorrow in class, that's fine. Okay. If you don't have math work to do, what are you supposed to do? Okay, bring something else. So if you don't have time to read page 153 tonight, just bring your book, or maybe I'll even pull up 153, put it up on the overhead tomorrow, and you can just read it off the screen. Yeah.
Is every Tuesday office hours or just?
Quite a few of them, but not everyone. Okay, kind of slide it around wherever it's needed. Okay. Any questions? Okay, let's take a look at this. Okay, this should look kind of familiar, but it's slightly different than the problem that we had last time. And the new part comes down at the bottom because we're now equipped to do this. Okay, so now it's not just find the rate, now it's not just find the slope for this line, for the rate at which the land lines are decreasing. It actually wants us to come up with an equation for this line. Okay, now I'm going to show you two different ways to do this, and they're both really important. Okay, one's pretty straightforward, most people understand this. Okay, let's take this point right here, which is 2004, 178. And let's take this point right here, which is 2005, 172. And let's just write a linear equation for that. Okay, now if you've got a calculator, that might come in handy. Okay, so if a couple of you, would you grab a calculator? Because we're going to need to make sure we get the right numbers. If I find the slope is going to be 172 minus 178 over 2005 minus 2004. So we got a 1 on the bottom, that's a piece of cake. We got a -6 on the top. So we have a slope of -6. Everybody okay with that? Okay, now, y minus y1 equals mx minus x1. Now you might say, well, wait a minute, Mr. Laws, why don't we just write this in slope-intercept form? Because we know what the y-intercept is. Is that the y-axis? Can somebody tell me how you know it's not the y-axis? John?
The year isn't 0.
The year isn't 0. If we were on the y-axis, the year would be 0. Okay? So it doesn't work that way. Okay? So we're going to write y minus, I'm going to do this one right here. So this is going to be 178. Slope is -6. X minus, what year am I subtracting? 2004. So here's where the calculators come in. Y minus 178 equals -6x. That's a piece of cake, but then I need to do -6 times -2004. So let's see, if I multiply the two of those together, that's going to be like 12,024.
Yeah.
So I've got 12,024. And then I still need to move this over. I mean, it's a story problem. We ought to make this look a little bit graph friendly. I'm going to add 178 to both sides. So I'm going to get -6x, and then this would be, let's see, plus 1, 2, 1. Nope, that's going to be a 2, isn't it? 202?
Yep.
Yes.
Okay. There it is. And that's in millions. So really, that number would represent, like, let's see, if it's in millions, you'd have to add 6 zeros. So that actually represents 12 billion something would be the y-intercept. That's a little bit of a pain. Okay? But, I mean, that's still pretty easy, though, isn't it? Okay, are there any questions about that? Okay, then I need you to watch, because this book does this all the time, as do most other textbooks. So you better make sure you read the questions carefully when you come across something like this. Most of the time when you're doing a problem like this, they'll say something like this. Let's count the number of years after 2004. So if we count the number of years after 2004, well, 2004 is right on 2004, so it would be 0 years after. What would this be? This would be 1, this would be 2, 2007 is 3 years, and so forth. Okay? So I'm going to write points that look like this. T, and we'll use, what are we going to use? L for landlines. So this one is going to be 0 and 178. This one is going to be, how many years after 2004 is this? 1 and 172. Now watch real carefully. 172 minus 178. 1 minus 0. Still get negative 6, right? But what's nice about this? Yeah, that is the y-intercept right there. So whether I use that or plug it into this, this is going to be y minus, y1 is 178, negative 6, x minus, what's x? 1? 0. So it's going to be y equals negative 6x, and this is going to be plus 178. That makes a lot more sense, because where does this say it crosses? At 178, and does it look like the slope is negative 6? Okay, see how that works? Okay, they could also do something where they say this. Okay, you with me? Same problem we did before. It was the one about the housing and how the median home size was going up. Okay? Let y, let's do this. X equal number of years after 1990. Whoops, 1990. So if it's 1994, how many years after 1990 is that? 4. What was the size of the homes? 1951. So 1994 is 1,951 square feet, is 4, because that's 4 years after the year 1990, and 1,951 square feet. Okay, next one. Let's see, the year 2006, 16 years after, median floor size. Okay, so all that does is make the numbers smaller. Okay, but you do have to keep track of this. They will usually tell you, hey, let's start measuring our time from 1990. And the reason that makes the problem simpler is, if you're starting at 1990 and your measurements are in the 90s and the 2000s, you're here. If we started at 0, okay, 0's way back there, and we have to go to 1994 before we get any data. Does that make sense? Okay. So when you read the problems, make sure you catch when they say where they're measuring from, because all they're trying to do is to make the numbers smaller and easier to work with. Okay. Any questions? You sure? Okay. So we've got 10 minutes left. That's enough time to get something done. Okay, remember, tomorrow's a Q&A day, so if you're done with this tomorrow, great, bring something else. If you walk out of here and still have 18 problems left to do, or whatever it happens to be, do you have time tomorrow in class to do them? Absolutely, okay? But if you want to get them done and then work on something else, that's fine, but everybody needs to have something to work on, yeah.
Will you count it as late if you're doing it in class?
No. As long as, let's not, Tyler just asked a great question. Will I count it as late if you work on it tomorrow in class? No, not as long as it's done by the end of class. So don't leave you any more that needs to be done other than what you can do safely